Picture the ugly ticket. A laptop is stolen from a car. The user had a normal SSH private key in .ssh. If that key was weakly protected, or the agent was abused while unlocked, you have an incident. Now change one thing. The SSH key is backed by a FIDO2 security key, like a YubiKey. The file on disk is copied, but the actual signing secret never left the token. No token, no SSH signature. That is the value we are building today. OpenSSH has special key types ending in -sk. The common one we want is ed25519-sk. The SK part means the private signing operation is handled by a FIDO2 authenticator, not just a file on your laptop. A YubiKey is a common device, but the idea is not vendor-specific. Any supported FIDO2 security key can work if your OpenSSH build has security key support. This exists to reduce the blast radius of stolen files. A copied .ssh directory should not be enough to log in. The server still sees public key authentication, but the client must ask the hardware token to sign. When you generate an ed25519-sk SSH key, OpenSSH talks to the security key through the system FIDO stack. The token creates or protects the credential. The file in .ssh is still called a private key, but it is not a normal extractable private key. Think of it as a wrapped handle plus metadata. To authenticate, SSH asks the token to sign the login challenge. The token usually requires a physical touch. That touch is user presence. A person is at the device. It is not magic identity proof. If someone steals the token and has the local key handle, touch alone may be enough unless you require PIN or user verification. First, check versions with SSH-V. Security key support arrived in OpenSSH 8.2, though some distributions backport features. Next, ask the client what key algorithms it knows. You want SK-SSH ed25519 at openssh.com and that output. On the server, sshd-T prints the effective configuration. Prefix sudo if your system requires it. Confirm pubkeyacceptedalgorithms has not been restricted in a way that removes SK keys. Then generate the key. Insert the token, run ssh-keygen with type ed25519-sk, and touch when prompted. Finally, install the public key for your account on your own host with ssh-copy-id. The protection pattern is not one magic key. It is two separate hardware keys, primary and backup. Plug in the first token and generate Y1. Remove it. Plug in the second token and generate Y2. These are two different SSH credentials, not copies of the same private key. Install both public keys on the server for the same account. Test both before you need them. Carry the primary. Put the backup somewhere controlled, a safe, a locked admin cabinet, or your break glass pouch. Label it, document what accounts it protects, and record the recovery process. Do not wait until Friday night to learn your backup was never enrolled. The first mistake is enrolling only one security key. Hardware fails, it's lost, gets washed, and gets left at home. The second mistake is assuming every SSH server accepts SK algorithms. Modern Linux usually does. Old appliances, stripped containers, and restricted SSHD configs may not. The third mistake is overselling touch. Touch means user presence. It prevents silent use, but it does not prove the right human is holding the token. If your device and policy support PIN or biometric verification, look at Verify Required and test carefully before enforcing it. Also, keep your normal account recovery path sane. Lockouts are a security problem too. In our SSH arc, this sits after normal public keys and before stronger fleet patterns like SSH certificates, bastions, and centralized policy. A hardware-backed key improves the administrator workstation. It does not replace server hardening. You still disable password login where appropriate. Limit users, monitor auth logs, patch OpenSSH, and control sudo. Security keys also work well with SSH agent, but remember that the token must still sign. In larger shops, the next step is usually hardware-backed user keys plus short-lived SSH certificates. That gives you strong possession at the edge and clean authorization on the server side. Here is the safe 5-minute lab. Use your own machine, your own VM, or a test cart. Insert the security key and generate a lab key using the command on screen. Set a passphrase when prompted. It protects the local handle if your laptop is stolen. Touch the token when asked. Print the public key with ssh-keygen-y so you can see that OpenSSH can derive the public side. Install the .pub file on a test host, then connect with ssh-i using the lab key. Now unplug the token and try again. 3 beats to keep. First, ed25519-sk makes SSH authentication depend on a FIDO2 security key, not just a copyable private key file. Second, touch is user presence. Useful, but not the same as knowing who the user is. Third, deploy 2 keys from day 1, primary and backup, both tested on the server. Before using this in anger, verify client support, server support, and your recovery path. Tomorrow we keep building the practitioner layer of SSH administration and defense. New SSH episode daily on this channel, plus the daily ranked CVE brief for what needs your attention now.